Students will take one more question on Prism formula, that is number 11. A glass prism has minimum angle of deviation of 40 degree. There is a glass prism whose angle of prism is 60 degree and minimum angle of deviation is 40 degree. It's not minimum angle of deviation is 40 degree. The prism is placed in water. That means initially it is not placed in water. When the refractive angle of minimum deviation is 40 degree, at that time it is not placed in water. It is placed in water afterwards. When the prism is immersed in water of refractive index 1.33, what will be the new minimum angle of deviation? This is the question. Now, how to solve this question? There are two situations we have to understand. First situation, I will write situation 1 here. The first situation says that the prism is in air. The second situation, the prism is in water. So the ray which is traveling here has minimum deviation of 40 degree. So first case. In the second case, this is minimum deviation, delta m I will say. In the second case, it is delta m prime. So our aim is to find this, the new minimum angle of deviation when it is immersed in water. So we have to write the formula 2 times. You write the formula once for air and then for water. Then we'll solve it. See how it is done. So when it is in air, we have in air, mu is sine of a by 2. Okay. Now, if you put those values over here, you will get the value mu. So first we get the value mu from here. Comes out to be is 60 plus 40 this is sine 50 degree divided by sine of 30 degree. Okay. So sine 50 by sine 30, sine 30 is half, so it goes 2 times sine of 50 degree. We must know that if I solve this here, I will get, let me check out what is sine 50 over there. Sine 50 degree, sine of 50 degree 0.77, 0.766, 0.766. So this is 1.532. This is the refractive index of the glass, that is the material of the prism from which it is made up of. So the refractive index of glass with respect to air is this. This is the case. But now when that prism is suspended in water, we will consider the refractive index of glass with respect to water. And in that case, what is the angle of minimum deviation? So in second case, when prism is in water, the mu of glass, that is the prism, with respect to water you have to find. Therefore, here it will be sine A plus delta m prime divided by 2 divided by sine of A by 2. We must note one thing, that the angle of the prism will not change. The deviation angle will only change. Therefore, by putting those values known data over this, we will get the value of delta m prime. So I'll write here that sine of from here it is sine of 30 degree, because 60 by 2 is 30. This is refractive index of glass divided by refractive index of water. The refractive index of glass divided by refractive index of water. So this is half into refractive index of glass. We already calculated 1.532 divided by 1.33. This comes out to be 0.57, nearly 575 or 576. This is the value for A plus delta m prime divided by 2. Now you have to check this angle, which angle gives you 0.57, and so we'll take this value sine inverse of this, which is 35 degree and 16 minute. This is 35 degree and 16 minute. So I'll write 35 degree 16 minute. 1 minute 60 seconds and 1 degree 60 minutes. So I multiply this 2 over here, and I will get the value of delta m as this minus A. So A plus 2 is 16 minute. A plus delta m prime by 2 is 35 degree 16 minute. Multiplying this 2 here, $70 and 32 minute. From here, delta m prime is minus A. A is 60, so I'll put it here 60. So I'll get 10 32 minute. So this is the answer to this question. It was obvious that the angle of minimum deviation will drop, because when mu is directly proportional to, in one way, to the angle of minimum deviation, because the sine curve is like that, like this. So from 0 to 90, the sine curve is increasing in nature, like so. This is the sine curve, and mu formula is sine of A plus delta m by 2 and divided by sine A by 2. That is not important. Basically, if you look this mu and this, because these are fixed, so only this value. If this increases, then this whole thing will increase. Then this whole thing will again increase, like this. So as the initial condition was the glass with respect to air, and the next condition is glass with respect to water, so this is reducing. This value will drop from certain value to certain value, so therefore the delta should also drop. So that means delta m should be less than delta m, which is also here. So delta m prime should be less than delta m, which is 40 degree there, now it is 10 degree and 32 minutes. Okay, thank you.